Hello and welcome to the Beef Nutritionist webinar. I'm Marianne Fessenden from AMTS and your English language host. This is the final webinar of the year focused on beef nutrition. The series is co-hosted by Paula Trillo in Cordoba, Argentina, who I just gave a heart attack to when I told her, maybe we're doing this tomorrow. She is translating for the Spanish-speaking audience. There will be a question and answer period immediately following the presentation. Listeners can submit questions through me or Paula. A complete recording of archived webinars as well as the question and answer sessions for each will be available later on the AMTS website, and I'll email you though when they do appear. For those of you who would listen to the presentations while driving, we have converted the videos to MP3 files that can be downloaded to your device for offline listening. I am going to introduce Dr. Nicolas DiLorenzo from the University of Florida, speaking on forage utilization practices to lessen the environmental impact of producing animal protein. Dr. DiLorenzo received his degree in agricultural engineering from the Universidad Nacional de La Plata in Argentina. He completed his study at the University of Minnesota, where he focused on animal science with an emphasis on beef cattle nutrition. In 2010, he joined the faculty of the University of Florida as an assistant professor in animal sciences at North Florida Research and Education Center in Marianna. His primary research and extension interests are in the area of beef cattle nutrition with the objective of improving the efficiency of use of forage, minimizing and the environmental impact. His research focuses on ruminal metabolism and fermentation, emissions of greenhouse gases, and nutrient excretions in cattle systems. I do want to remind our audience to write questions in the chat or question and answer window. Very shortly, I'll turn over control to Nicolas. This has been a challenge as we were scheduled back in October, and a hurricane came through and made it so that Nicolas is still compromised in terms of his power and his internet ability. So he had to travel to another city in order to deliver this. And the email he sent out last night arrived 15 minutes ago telling us, I'll talk to you tomorrow. And that sent me in a little bit of a panic, worried that he wasn't joining until Thursday. So it's all good. He's going to take control of the slide set. And let's see, I will unmute you, Nicolas, so that you can speak. All right, you're good. You're open. Go ahead and say something.
Okay. Can you hear me okay? Thank you very much. Thank you, Marianne. Thank you, Paula, and my apologies for the scare. I guess that when I sent last night, it's the same set of slides that we had for October 10. The only thing I had was updated this one that we're seeing now to today's date, and then a couple pictures that we'll see here in a few minutes if Marianne was able to introduce them. I can show you some of the reasons why we had to reschedule. So it is my pleasure to be part of this series of webinars, and I'm really thankful for IMTS and Paula and Marianne for the invitation. I think it's a great opportunity to share some of the things we're doing at the University of Florida, particularly in the North Florida Research and Education Center where I'm located. So I'm going to jump right into, basically I can almost skip this slide. So I'm going to start with all the animation. This is a brief history of what I did and how I end up where I am right now. So it shows basically my first steps when I started in the U.S. with as a trainee for the MASS program. Some of you that may be aware of that, or they know the Minnesota Agricultural Student Trainee Program. That is program that through the University of Minnesota that places students in different parts of the country. I was fortunate to work and live in Northwest Iowa. And part of that was working with beef cattle, hogs, and a little bit of corn and soybeans. And Paula, I will apologize, or the translator in Argentina, I'll try to slow down as I remember, because I know how challenging that can be. So then I moved. After that, I went back to Argentina in year 2000, and I was invited to come back to the States in 2002 to complete my master's and PhD at the University of Minnesota. Spent some time as lectured at the University of Wisconsin in River Falls. Then did a 2-year postdoctoral research associate work at Texas Tech University, focusing mostly on feedlot nutrition. And then, as Marianne said, I've been since 2010 at the University of Florida, first as assistant professor and most recently as an associate professor. This is how I felt basically arriving in Florida in 2010 with my background in feedlot nutrition and going through the Midwest, 6 years in the Midwest, 2 years in the Southern Plains in Texas. And I felt that that's how people in Florida were going to receive me. Was not true. This is where I'm located. As Marianne indicated, I had to travel to that. In this map, you cannot see it, but basically it's an hour north of Orlando where Gainesville is, the campus, main campus for the University of Florida. So I'm giving the seminar from there. We have a much more stable internet connection. It is a 3-hour drive, so but it was a great opportunity to also be able to have better connection and also meet with some of my other researchers here. So I wanted to share this 2-3 slides of something that you may or may not know, that's the main reason why we had to move. I put in blue there where Marianna, Florida is in the Panhandle. We were hit by Hurricane Michael. We were 2 miles shy of being a Category 5 hurricane. It was 155 miles per hour. I put it in kilometers there, 248 kilometers per hour winds. The city is pretty much devastated. We still have some issues at the research facility where I worked at, but I might be able to show you some of the slides. This is our downtown area of a small town of Marianna, 15,000 people, and this is what some of the buildings look like. This is the coastal area of Mexico Beach that was impacted by the hurricane, and it's pretty much gone. A few houses, should have been houses all the way to the beach there. What you see there is pretty much devastation that caused. And I couldn't find any pictures of our research station, but a lot of it looked like that, except that picture those electricity wires are actually our fences. So that's how our research facility looked like for the past month. So slowly we're getting back on our feet, trying to get everything fenced and back in business for research purposes. So this is some of the pictures of what we have in our facilities at the research station where I work. We have about 300 plus cows, mostly as a beef cattle operation with Angus, Brangus, and Brayford animals. About 1,000 acres of pastures that include 52 replicated pastures that range in size from 1.7 to 3.3 acres. We have several of those different sets for different research purposes. And my research program, and Marianne briefly touched on this, can really be summarized in 3 areas: the manipulation of ruminal fermentation to enhance beef cattle productivity and prevent metabolic disorders. I've done a lot of that work back in my days in Minnesota when I did a little bit of rumen microbiology, working on acidosis and other metabolic disorders, and improving the efficiency of digestion of feed resources. I would add with an emphasis on forages, which is what I will cover today. And then assessing and mitigating greenhouse gas emissions to livestock system, which is an area that has really been very interesting for me to develop in recent years. The main reason why all of this is relevant, besides for all of you that are in the field of animal science, is it may be redundant, maybe the numbers are not, hopefully, but if you think about the solar energy that the earth captures in the form of biomass, so primary production, converting CO2, fixing it into carbohydrates, only 5% of that is potentially available for human food directly. The rest has to go through a system like that, basically a ruminant, to be able to convert it in high quality protein, such as different meat products and dairy products. So the reason that we are able to do that is because obviously the intestinal tract of ruminants is equipped with this fermentation vessels that can harbor this type of microorganisms. Here in this picture, we have on the same picture protozoa, and the ventral part, we have bacteria attached to that, and then a fungal spore on the side. So it represents the three main groups of microorganisms in the rumen that are able to digest fiber. So well, the reason why this is relevant, and in the case of so going to a bigger picture from the rumen microorganisms, if we look at the U.S. in general, we have about 28% of the beef cattle. It's in that area that it's sometimes referred to the South or Southeastern states, and most of the production in this area is based on forages. So that's the reason why most of my presentation from now on will focus on forages. So, and how can we improve the digestion of those forage resources? There's a huge relevance in terms of grazing systems, in terms of nutrient recycling. About 70% of the carbon that is consumed is released as carbon dioxide and methane, and then 70 to 80% of the nitrogen consumed is excreted back in the soil and ends up urine or dung. So as a byproduct of that, we have greenhouse gas emissions. That is sometimes I refer to, or I tell my students, is a tax that we have to pay on the cost of doing business for being able to digest some of those carbohydrates, mainly cellulose, the most abundant carbohydrate on earth. We have to pay a tax for that, which is the production of greenhouse gases, mainly methane. If you look at in the United States, 40% of the emissions in agriculture are due to livestock production. But if we compare that with other sectors, agriculture only accounts for 9% of total. We have large electricity and transportation sectors in the U.S., so agriculture, it's only a fraction of that. But on a percentage basis, it is a fraction. But I'll show you in this next slide here what happens when we convert percentages to actual amounts of greenhouse gas emitted in a yearly basis. So if we look at the United States, the production of carbon dioxide equivalents, it is about 234 million metric tons. And the way we express, and when we talk about greenhouse gas emissions, we typically talk about carbon dioxide equivalents. So everything, methane, nitrous oxide, all the other contributors as far as greenhouse gases, they get converted to carbon dioxide. But when we look at that amount, it equates to more than half of the total greenhouse gas emissions that are produced in Spain in a year. So total, including transportation, etc. We're talking about an industrialized country. So as a comparison, that 9% in the U.S. with a large industry segment, it may not seem that relevant, but in terms of absolute numbers of greenhouse gases produced in a year, it's a very substantial amount. And this slide only shows the breakdown of the different categories of animals, and beef cattle has the largest share, mainly because there is 10 times more beef cattle in the U.S. than there are dairy cattle. So about 9 million head of dairy cows and close to 100 million in terms of beef. So that is the main reason why this graph shows beef cattle as the main contributor to greenhouse gas emissions. In the north part of Florida where I worked, we have systems like this in which we work heavily with an integration in terms of forage and crops. So what you see there is a large project that we have, and exclusion cages here and here, in which cattle are not allowed inside, and we use that to look at the impact of cattle in terms of nutrient cycling and greenhouse gas emissions from the soil. This project has been funded by the USDA, and we had several years of data and very interesting results. And in a nutshell, this is what the project looks like. It's basically a rotation of peanuts followed by cotton and 2 years of Bahia grass. So this is the scheme of the USA funded study. Basically, we have a total of 160 acres in one of these pivots divided in quadrants of 40 acres each. And each year they rotate in this direction from peanuts to cotton, then Bahia grass on the first year and Bahia grass on the second year. The whole idea with that is to build to improve soil health and definitely get a boost in the production of peanuts and cotton due to mainly more organic matter and nutrients returning to the soil. So this is that same system maybe in the summertime. So in North Florida, it's a very important part of the production system is that rotation. It's not something that it is new. It's been done for years. And to further illustrate why that is important, I will show you here. This is the winter time. This will be 3 months from where we are right now. Will be about January, February. This is what it looks like in a triticale plus ryegrass pasture, and this is what it looks like in the top part without that. So that would be basically a dormant Bahia grass or Bermuda grass, or two main forages. So there is not much forage in the wintertime unless we plant some. And this is what it looks like in the middle of that grazing season. So going back to the title of my presentation, any way we can make more efficient or make the use of all this green forage more efficient, it would definitely contribute to reduce greenhouse gas emissions and consequently the carbon footprint of beef production. So a lot of my work has centered on how to better use those forages. The biggest challenge that we have in terms of that is the use of or the ability to quantify feed intake in grazing conditions. We do have a system called GrowSafe. You can see it here. It is a Canadian-based system that allows us to track intake on basically it's a feed bunk on load cells. Cattle wear an RFID tag on the left ear. Every time they cross this barrier, there's an antenna in this bunk that picks up that cattle number, in this case 1, 2, 3, and it will tell us the weight change of that feed bunk. So we know exactly how much that animal's eating and at which rate it's eating, how many times a day it visits that feed bunk, etc. So it is a very unique system that we take good advantage of that, and I will explain in detail what this color is, because that is part of our greenhouse gas emissions measurement. Just a quick check, Marianne, how is the sound so far? Or has it improved or has it gotten worse?
Actually, it has improved, I think.
Okay, perfect. I'll try to slow down and see if that may help on that.
Okay, good. Thanks.
Thank you. Part of that project that I was telling you about has been funded by the USDA. It's a large 4-year project that involves placing this type of devices that I will explain in a minute into the animals that will allow us to track greenhouse gas measurements on a daily basis, basically, or on a average over a 5-day period on grazing animals. That technique, it's called the sulfur hexafluoride tracer technique, and I will tell you now in a minute in detail what that technique consists. But you can see that in certain animals in the pasture, in this case, out of the 5 animals in the pasture, 2 are wearing those collars. And the way it works, in this slide is probably showing more detail. This canister or yoke, it's basically evacuated, so it's under vacuum. And then we put a halter in the animal that you can barely see maybe here closer to the nostril. So the animal, as it belches, it captures that emission basically into this tube. And it does so for 5 continuous days. Every day we replace this canister, so we put a new one, and in the next picture I'll show it well. We take that device to the lab, we hook it to a gas chromatograph, which is this machine here, and it will tell us the concentration of methane. by using a tracer, which is a sulfur hexafluoride, which is you can think about it as a small pill that we dose the animal with. That allows us to track the emissions of gas on a daily basis. So all of this is called, like I say, the sulfur hexafluoride or SF6 tracer technique, and today is one of the few, or almost the only technique that would allow to measure methane emissions under grazing conditions. So I'm going to switch gears now to talk about one of my most recent projects that were aimed at improving the digestibility of the forage resources. I just show you how we measure methane, and we did that in this project. This is Francine Henry, one of my PhD students. She's graduating this year in about a month. She has done pretty much her entire PhD work with the use of chemical treatment, and more specifically calcium oxide. We've been playing with the idea of calcium oxide or quicklime as the main alkali to treat forages. We're in an attempt to improve digestion. This is how it works, or at least the proposed mode of action. Calcium oxide, upon contact with water, will release heat. So it's an exothermic reaction. And also will form an alkali, calcium hydroxide, that basically attacks those cross links between cellulose and lignin. So the hemicellulose, which it's represented here by this bound, the sheet that basically goes around this cellulose fibers, and the cross links, those are all different forms of hemicellulose. And the alkali, it's supposed to hydrolyze those and make more accessible the digestion to the microbes to be able to digest those fiber resources. So calcium oxide is also called quicklime. Other forms are the slake lime or calcium hydroxide, which is basically the same version of the calcium oxide, but with after it's been going through the process of water addition, so it's hydrated. And what we did in this particular experiment, actually it's a series of experiments that I'm going to show here. What you see, PM, that stands for Bermuda grass, and BH stands for Bahia grass. Those are the two main forages that we have in Florida, and they are considered average to maybe low quality forages, and especially in comparison to cool season forages. This particular experiment was repeated over 2 years with 4 replicas per treatment, and I will describe briefly our 6 treatments here. Dry hay, hay plus water incubated for 7 days, hay plus water incubated for 14 days. As you can see here in the bracket, the water addition was always up to 50% dry matter, and the addition of water is to facilitate that hydrolysis of calcium oxide that I showed you in the previous slide. Calcium oxide at 5% of the dry matter incubated for 7 days or 14 days. So those are the acronyms, CO5-7 or -14. And then the last treatment, we wanted to explore incubating for 14 days with 10% calcium oxide, which is, it's quite a bit of calcium oxide. We put that in 20-liter buckets. After we ground the content for 4 millimeters, then we then incubated that forage that has been treated with the alkali in situ, so inside the rumen of cannulated animals, for several incubation times. And I probably will concentrate only on a few of those. And then we did in vitro organic matter digestibility by grinding it further to 2 millimeters, as it is typical for this assay. Here are some pictures of that. We added the calcium oxide, then we added the water. It was mixed by hand. It's caustic, so I had to be very careful. It is an exothermic reaction, so we had to wear gloves. And then they were packed into this 20-liter buckets and incubated for the 7 or the 14 days. We also did what you see here, PHS is peanut hulls. Was another of the fibrous byproduct that we attempted to use. You will not see me present much of that because basically it didn't work. We had a very a very interesting situation where a lot of mold was developed, which maybe wasn't surprising considering that these peanut hulls are grown underground, or the peanuts are underground, so they were loaded with probably fungal spores, and a lot of germination happened. So we didn't see much of an improvement. The only thing I can tell you is we got about 20% digestion on this type. Moving on to the hay that we did incubate, this is what it looked like after our 7 or 14 days of incubation. And these are the first results after 48 hours. You have to recall here your acronyms. So dry, wet, 7 days, wet, 14 days. So these two are just water. These two are 5% calcium oxide, 7 or 14 days. And this is our 10% calcium oxide for 14 days. So basically both forages, we saw an improvement, a drastic improvement, I'd say, in the digestibility. This is in vitro organic matter digestibility after we incubated them. And that was very encouraging for us. So if you compare to the dry hay at a 40% digestibility, which tells you right there the difference between Bahia grass and Bermuda, about 10% more, or 10% units of increased digestibility in those two. But when we added the calcium oxide, even at the 5%, we already have in Bermuda grass in the neighborhood of 60 to maybe 65% digestibility. So it's a significant improvement. Same with Bahia grass. So it goes from 40 to 57 on the 10%, but mainly 45 on the 5%. So bottom line of this, it seemed like our alkali treatment was working, which led us to what I may call as what it was a logistic nightmare, this project. It was a follow-up project from the previous one, but in vivo. So here we had round bales of hay that were ground into a mixer. Then we added the water and the alkali in this order. Alkali first and the water into the mixer. So what you see here is my student Francine. She is climbing onto the mixer and adding water up to the amount that we needed. And then we repackage that bale into square bales that were then placed into garbage bags and vacuum. So we use a vacuum to eliminate all the air, and they look like this. So this is all done for experimental purposes. And we fed it to cattle in our confined operation that you saw earlier, where we have the feed banks on load cells. So we have untreated dry Bahia grass hay, the hay treated with close to 9% calcium carbonate. This is an addition. We didn't have it on the previous treatment, but basically we wanted to balance for the amount of calcium that we were feeding. Just make sure that calcium was not affecting our results. And this is our treatment of interest, our 5% calcium oxide plus water. So we have about 8 steers on each. We have an extra steer on the calcium carbonate treatment. And I can summarize. I'm not going to walk through all the details because I can summarize this fairly quickly. Basically, our calcium oxide treatment did not perform as we hoped. We had an increase in protein intake. That was what I was showing earlier. But this is the interesting thing is that dry hay compared to calcium oxide, remember we have calcium carbonate in the middle. Calcium oxide, our treatment of interest, did not improve. If anything, actually made it worse in terms of NDF digestibility. We're still trying to figure out why, but both NDF, neutral detergent fiber, and ADF, acid detergent fiber, were decreased with calcium oxide. This was confirmed by volatile fatty acid concentrations in the rumen. These are cannulated animals, so again, I'm not going to go through any of this in detail. If you want, we can concentrate on the total volatile fatty acid concentration. It was decreased on our calcium oxide treatment, not that much, or actually not decrease at all in the calcium carbonate. So we are not sure. We hypothesized that maybe mold had to do with that because the hay had a particular smell. The intake was not great. I mean, cattle consume close to 1.1% of their body weight, which is well below what we normally see for that. However, when we did take samples from those square bales, we did see an improvement in the digestibility in vitro again. So something going on with perhaps the intake or mold that basically we don't see the effect of mold perhaps on the in vitro digestibility, but something's telling us that our in vivo results were not matching the in vitro in terms of digestibility. And so basically a summary from that study is that we had no difference in dry matter intake. I did not show you the slide on pH, but as expected, the calcium oxide, which is a strong alkali, increased ruminal pH, and there was a decrease in both fractions of fiber digestion, of digestibility of fiber in the total tract. So we use indigestible NDF as a marker for that. And the total VFA concentration, as would be expected from this comment from the decreased NDF and ADF digestibility, total VFA was also decreased. So that told us that we had basically a decrease overall fermentability in those diets. And surprisingly, in our in vitro studies out of that same bales, we had an improvement in IVOMD, so in vitro organic matter digestion. So with that, we reformulated another study, and I'm being very unfair at presenting all of this in such a short frame, but this involved almost 3 years of work that Francine did, so I'm going to try to fit all of that in the context of the seminar, but I'm only presenting the most relevant part of that. So we then concentrated on Bahia grass, so Paspalum notatum, the most common low-quality forage we have in Florida. And then we treated with calcium oxide. This time we added molasses to see if maybe we can overcome palatability issues. We basically wanted to ensure the cattle will eat. And we know from previous experience that they will eat anything that has molasses. So this study was also conducted at the North Florida Research and Education Center. We had 96 growing animals. We have 59 heifers and 37 steers of approximately 250 kilos. And we assign them to 24 pastures. This is part of what I told you in the beginning. We have several replicated pastures of, in this case, 1.34 hectares each within 2 locations in our unit. And so this was a performance study. Basically, we were looking at animal performance. And then the 3 treatments were, as always, we had our untreated dry Bahia grass hay. So this is just the same hay, round bales placed in the pasture. Bahia grass hay, so the same hay, same cut as this one, but treated now with 10% molasses on a dry matter basis. So basically we took the dry weight of that bale and we added molasses to 10% of the total. And then water to 35%. We started playing with a 50% water treatment, and we realized that a lot of that molasses and water was coming out on the other end of the bales. And I will show you now how we treated that to maybe clarify that. So we figured that with having 35%, so basically 65% moisture, it should be sufficient to be able to create that condition that calcium oxide would be hydrolyzed. So we then treated, and then we have our typical treatment, the one that we've been testing, which is the calcium oxide at 5%. In this case, we added 10% molasses. So basically, these two, the blue and orange, are the same treatment with the exception of one has calcium oxide, the orange one, the other one doesn't. We have 8 pastures per treatment, and then 56 days later, we weighed the cattle. Here are some pictures of how we did that, talking about another very hands-on and very complicated study from the logistics standpoint. We have here Francine weighing bales, adding the calcium oxide and molasses, turning to this kind of brownish liquid. That then we flip the bales to the flat side. We pour the treatments and we flip them back as quick as possible into the round form, so that we would avoid or minimize leaching of the liquid on the other end. And then we fed it, and cattle in this study tend to or seem to eat a lot more than in the previous study. So this is some of the measurements. We took blood to look at blood urea nitrogen as an indicator of protein status, and we took body weights at the beginning and at the end, shrunk body weights, so basically after they've been withdrawn from feed and water. And then we added another, so that I will present these two experiments together, because after finishing that treatment that experiment one, which involved those three treatments, so basically dry hay, molasses, or molasses plus calcium oxide, we realized that protein was perhaps going to be limiting this. And then we decided to start another experiment, which was basically eliminating the dry hay, so everything now will have molasses, and we kept only the molasses or the calcium oxide treatment, adding cottonseed meal at 0.3% of the body weight. The whole rationale with that, and you can see pictures from the trial down there, was to basically increase the protein supply to the growing animals to see if we could overcome any potential deficit in nutrition that it was due to lack of protein and not so much due to the calcium treatment. So here are the results of that. We have basically the contrast that you see there was the effect of molasses. So comparing molasses plus calcium. This is experiment one, by the way, the one with the 3 treatments. So the average of the 2 treatments that have molasses versus the one that didn't have molasses, so dry hay, we did not see any effect. And this was quite surprising for us. You can look at the gains. In fact, let me see if I have it highlighted here. You can see that on average, cattle lost weight. So we have a loss of, it was close to 0, but they lost a little bit of weight. Perhaps not surprising if we think that these were 250 kilos growing calves with very little protein, and that pushes us to do the study or experiment 2 that I showed you earlier, in which we discarded the dry hay. We had enough information about the dry hay treatment, and we decided to go with just molasses alone or molasses plus calcium oxide. When we look at the results of this, if you look at the difference, if nothing else, let me back up for a second to show you something I didn't highlight. We're back on experiment 1. Remember here, the gains were close to 0, okay? From 0 to 56 days, cattle did not gain anything. If anything, they just lost a little bit of weight. Now, 0.3% of the body weight in the form of cottonseed meal made a huge difference, to the point that now the same calves are gaining about 500 grams per day. And they were not different between calcium oxide or molasses. So basically, we had a very interesting effect of the protein supplementation at improving gains drastically, I would say. But sadly, we did not see anything again with calcium oxide. So we were designing an experiment to look at calcium oxide on methane emissions using the technique that I show you. So briefly, and these are pictures from the actual study. This was done almost concurrent with the experiment 1. So we have a dry hay, which again is our Bahia grass, or calcium oxide treated hay, Bahia grass hay. And then in this case, we did the 0.3% cottonseed meal, because we already have seen that we needed that in order to boost the performance. So if I ever were to recommend feeding this, even just dry hay, we would need at least to have that 0.3% cottonseed meal in this case to have a significant growth in those animals. We had 20 days of experimental period, and we recorded individual intake. This is what our methane emissions look like. This is done with the sulfur hexafluoride tracer technique. So we have fairly comparable numbers with what the literature has been reporting for this type of measurements, about 120, 110 grams of methane per day. And you will see it there expressed in different forms, but basically no difference here in the p-value on the right. P-value here on the right will show you that there's no difference in the treatment as far as reducing greenhouse gas emissions. This study was done with a lot of help. We have there, well, a lot of our students, Carla, Laura, Gonzalo, Barreneche, and Ana Gomez Luna helped a lot in our research during those days, and Francine, who led the study. We concluded on that study that Bahia grass hay treated with molasses alone or in combination with 5% calcium oxide did not improve performance like we expected. And then different techniques using calcium oxide should be further evaluated because we still get that improvement in vitro, and we feel that we may be achieving in vitro under controlled conditions. We are achieving what we are supposed to, but we are just not getting enough of a perhaps distribution of the alkali into the hay. So briefly, in the last maybe 5 minutes, I want to leave some time for questions. I want to share a study that we are also in the phase of completion pretty much, which is funded also by the USDA in looking at the effect of bismuth subsalicylate and encapsulated nitrates, and this is to reduce enteric methane emissions. Bismuth subsalicylate is basically the active ingredient in Pepto-Bismol, and we were testing it to see if we could have improvements in forage digestion, or more than anything in this case with the bismuth was to prevent metabolic disorders due to excess of sulfur in the diet. So I won't go into all the details of the study, but basically it was a 2x2 factorial. So we wanted to try nitrates, yes or no, bismuth, yes or no. And then we have what we call a negative control, which would have been one with only molasses. All of this other treatment had molasses as part of it. So the idea with the nitrate was to reduce greenhouse gas emissions. Has been shown that nitrates can replace urea and perhaps mitigate some of the emissions created from the enteric digestion. So we pretty much use molasses and sprinkle with either urea or nitrates on an isonitrogenous basis. On low quality forages, again, we use Bahia grass. And this is Darren Henry, who did this study, a PhD student, now professor at Texas Tech University. I'm going to concentrate on the results from the methane standpoint because this was quite encouraging for us. So if you look at, I'm going to walk you through this table, negative control. So basically hay and molasses only. Urea, so, and you can look at the details on the bottom, but basically we were doing 182 milligrams per kilogram of body weight of urea, typical of what is done in our area. Nitrates, then we have either urea or nitrate on an isonitrogenous basis, urea with bismuth, and nitrate with bismuth. So basically this is the combination of the four treatments. And what you see here is an effect of nitrate significant. So basically, let me see if I have it here. I'm not going to concentrate on any of the other variables for question of time, but this is basically the bottom line is whenever we fed nitrates or we replace urea with nitrates with a very careful adaptation, and I can tell you more about the adaptation later if you want, but the key was just to prevent toxicity in nitrate due to a very long adaptation, we were able to reduce methane by 11% in forage-based diets. So, in summary, for the entire seminar, in terms of improvement, calcium oxide used as a chemical treatment for hay was successful in improving forage digestibility when we did the in situ and in vitro trials, but every time we went to the in vivo, we failed to show that response, especially when we did it on large round bales. So some of our questions: is it a problem with the delivery of the treatments, bale injection versus TMR? Because we were basically trying to inject bales. We need to explore the alternatives, at least we believe so. We did not see effects of methane emissions with the calcium oxide treated hay. Whenever we use nitrates to replace urea in high forage diets, we were able to reduce methane emissions by 11% without any effect on performance, negative or positive. We were mainly concerned about potential negative effects due to toxicity or reduced fermentation, but we did not observe that. So that's a valid alternative. And this is my last or maybe second to last slide. So the main thing I wanted to concentrate on is that delivery of this active treatments, I think it should be further studied. There seems to be something in terms of improvement in fiber digestibility, but scaling those experiments to field conditions has been the largest challenge that we encounter here in North Florida. We are convinced that nitrates can provide an alternative non-protein nitrogen source that has been shown to reduce methane emissions without any negative effect on performance. And future studies, some of which we are doing now, should aim at improving fiber digestion in vivo, and concentration should be placed, and I cannot emphasize this enough, but I really think we need to concentrate on delivery, especially in grazing conditions. The biggest challenge that we have is how do we deliver that to animals eating hay or grazing. So delivery is by far a great challenge. This is Francine here in one of our attempts we actually devised an injection system where we would inject bales at 5 to 6 different points to see if we could deliver the treatments. We failed at that too. Then we started flipping the bales on the side in an attempt to have a more uniform delivery. Anything that we can do to prevent from having to grind the whole bale as a way to deliver the treated forage, it would be a huge improvement in terms of animal performance. So delivery, I think it's the key for future treatments to be able to work. And in forage systems, we have to rely on a way to be able to daily feeding those animals with something. And we do it for experimental purposes, as you can see here, every day weighing buckets and weighing little pockets with urea or nitrate, but future studies should concentrate on field applications that will be cost effective. So with that, I want to thank you for the time, and I will turn it over to Mary Ann, and I'll be more than glad to answer questions if we do have.
All right, Nicholas, thank you so much. And certainly we came a long way to get this webinar done this time. Thank you everyone for joining us. I hope
the quality of the sound was okay towards the end. I'm not sure.
Yeah, it was an odd fading in and out. And I had a suspicion that it had nothing to do with anything you were doing. I'm up here, maybe 1,200 miles away from you, and our news, Florida has sort of dropped out of the news because other things have happened, and there's wildflowers, fires in California. But every once in a while, it pops up just how bad everything still is down there, and we're all thinking of you. I was glad that you were able to be safe in October and not doing
Yeah,
a webinar.
that would have not been a good idea to hold the seminar that same day. It was actually scheduled the same day of the storm. So
Yes. I woke up early and looked at the news and said, we have just got to cancel this.
no,
And
it was a right call.
yeah. So also I want to just do a little bit of thanking. If while during this time period, if you have any questions, please type them in the question and answer window. I want to thank my co-host Paula Torillo, who I am sure will have many questions from Argentina. She is sponsored by Rock River Labs and Bio4 Argentina. I also wish to thank AB Vista, our English language webinar sponsor. The archived webinars of this and past nutritionist webinars will be available at agmodelsystems.com. Really, I promise. It's just been a little bit slow for me to get all of the webinars we've done this year translated, as well as running the new webinars and some other projects I've been working on. So look for them under the webinars tab. And I have not yet put any of the beef webinars up, but rest assured I have the recordings. I just need to process them. These webinars can be downloaded for offline viewing by clicking on the Vimeo logo on the video showing viewing window. The podcast conversion of the audio from the webinars can be downloaded from the podcast under the knowledge base and under webinars tab. These both allow you to listen to things, to download and listen or watch while not on the internet. So with that, I am going to see if I've got any questions, and if Paula has some questions, we will go ahead with that. I have a question to lead off, and then hopefully Paula, I'm going to have you unmute yourself because I don't know which of the Paula Torillos you actually are.
Yes, I'm here.
Okay, good. Recovered from your heart attack.
Yes, totally recovered.
Yes.
Okay, thanks, Nico. Great webinar.
Thank you.
A lot of information here.
All right, Paula, do you want to lead off with questions, or I have one that I can ask?
You can start, please.
Okay, all right. So this is from Ed Vanderpleg. He says, what sources of nitrates were used in place of urea? Was it ammonium nitrate?
Great question. Yeah, because I felt maybe on the rash too. I failed to describe more in detail, but it is calcium ammonium nitrate. The product, and we use an encapsulated. So you might have seen. I might have rushed to that, but you might have seen an E before and the acronym for that treatment, which stands for encapsulated calcium ammonium nitrate. The calcium ammonium nitrate was it was provided by GRASP, and it was graciously donated by GRASP, which I believe it's a part of the EW, and we really didn't know which source to use, and we really were not aware of many different sources, and we were lucky to run into Rafael Kanonenko, who was instrumental in also providing input on the design of that study, and then later providing all the nitrates from results. They had the sources, calcium ammonium nitrate, and we had to, encapsulation was done to perhaps help on the potential toxicity. And but I didn't have time to show some pictures. We did have some of that capsules or prills of calcium ammonium nitrate found in the feces. So if anything, another thing I could add to the conclusions is we might need to work on the encapsulation process in the future, or companies will need to work to perhaps reduce the encapsulation to some extent, because any of those prills that show up in the feces were definitely not of use for the animal. So, yeah.
Okay, Paula, would you like to ask a question?
Yes, I have a question from Pedro. He he wants you to explain a little bit more about the reasons why you think the calcium oxide didn't have the expected results in vivo.
Good, really good question. We've been hypothesizing, especially after 3 years of working on the same. We've really been thinking a lot about that. I can almost break it down by studies. On study one, if you remember, I don't expect you to remember, so I can tell you what it is. The very first one, we had square bales. That was done in the summer, and we believe that by wrapping the hay bales, we created conditions for mold development, and one indication of that was the low intake of that. So we had, like I think I say, we had about 1.1% of the body weight when we normally have at least 1.4 to 1.7% of the body weight and hay intake on similar forages. So we think that maybe intake had something to do, and cattle are very sensitive to the smell of hay that may be going through a molding process. So that's one potential. But if that would be for that particular one study. Later on, we kept improving our system to the point that I didn't spend time on that, but in the very last study, after treating the hay, we put it to dry in a concrete pad, and we sort of fluff it or turning over with rakes, and that was all manual basically, to dry it and ensure that we did not have the molding process. So, and we got much better intakes. I didn't show the intakes of that, but they were close to the 1.7% of the body weight that we expect. So I think if I had to summarize the question is, I think is delivery. If the conditions are not right, we can create mold and cattle won't consume it. So then we don't see the performance. But the point that the in vitro organic matter digestibility or the in situ organic matter digestibility, every time we've done it, it gives us an improved digestion. It tells us that perhaps the biology of the idea is working. So something is creating conditions to improve the digestion of the fiber, but only if we create those right conditions in terms of grinding the forage. You have to keep in mind that both in vitro and in vivo, we have to grind the forage, and as you saw in the first slide, we have a person carefully weighing the powder, adding the water, and mixing by hand. So I think that is a reflection of the biggest challenge that I tried to convey at the end, which is the delivery. I think if we figure out a way to grind, and I'm not, by no means I'm proposing this because from a cost-effective standpoint will be impractical, but grinding hay, adding water, and adding the powder and mix it intimately and allowing it to dry or to sit without developing mold, it would be the ideal condition, but it will be very impractical. So that's when we play with the idea of injecting the bales, pouring on the side. And at this point, I tell my student in charge of the project, I think we have more of an engineering issue than a science or an animal science problem. I think the biology seems to work and has been widely documented in other studies in Nebraska with corn residue. Corn stover has been widely published, and 5% calcium oxide does improve digestion. The problem that I find in this system is the delivery, how to figure out a practical way to deliver the calcium oxide so that it's intimately in contact with the fiber and for the amount of time that it's required for that reaction to take place. So we have a hypothesis. We really haven't figured out the main reason, but I think molding definitely one of them that we need to avoid.
I think Paul is busy translating questions. I'll go ahead. I have another question from Ed. Oh, go ahead, Paula. Sorry.
Okay. This is related with what you just told us. Why didn't you think of applying the calcium oxide before collecting it from the soil, before collecting the forage from the soil?
Great. Yes. Excellent question. In fact, so yes, that is. I have two or three ideas to follow up on this. So after working 4 years with calcium oxide, well, the student that was working on this, she's tired of calcium oxide. I don't think I can convince her to do this, but we have discussed this in detail, and one of the ideas would be to apply it in the windrow, basically after the forage is cut and lay down for hay production, to come down and sprinkle maybe the windrow, and then pick it up with a baler. That was one of the ideas that was discussed, and I think it may be the way that we would do it that way, or even with a sprayer, like the way that people will do haylage, and they will spray perhaps an inoculant as they are picking up the bales, something like that, where a solution of calcium oxide could be sprayed. We play with that idea too, and it is likely that we'll do it in the future. So basically, trying to figure out a way to add it to do it before baling. The biggest challenge with that, and that's the reason why we haven't done it yet, is that we know that if we bale and if we happen to wrap any of these forages with high moisture content, we are favoring conditions for spoilage because pH is going to be increased. One thing we notice is calcium oxide, as it should, dramatically increases the pH of the forage, which goes against what we want in a good conservation forage program. We want to drop that pH as quick as possible. So calcium oxide acts as a strong buffer and a strong alkali. So that was the only thing that will be a challenge. If we do that, we will have to let it dry and bale it dry. But after the powder has done its effect on the forage, so it's a really good point, because we've been really discussing that.
Okay, thank you. I have a related one, and you may have covered some of this in your discussion. And I know when I was in the UK, maybe 5 years ago, they did do some treatments of different forages. But this person asked, can you not apply the mixture of calcium oxide at the point of baling or ensiling? Here in the UK, we add additives to silage via the forage harvester or baler, which gives really even coverage on the whole crop.
Mm-hmm. Yes, that would be ideal. We've been working with even some of the manufacturers to figure out a way to do it. And I don't think from a standpoint of the application itself, I think it will work perfectly or even better than just a matter of regulating the amount that we're dispensing. I don't think that would be a problem at all. My biggest concern again would be if we wrap that. If we're adding that means that typically is done when in a wet forage. So we're going to bale it as haylage. If we're going to bale as haylage, we need that lower pH to be able to preserve the forage. And here we're adding something that for sure is going to increase. So we might do that on a small scale at the beginning to see what are some of the consequences of that. And so we're definitely thinking about that, but we're worried about the possibility of creating conditions where that forage that is wrapped will not preserve well.
Okay, thank you. I have another question, and then Paula will have some questions. For delivery purposes, have you considered doing a trial using a lick wheel tank to deliver molasses, nitrates, and other supplemental nutrients, vitamins, minerals, etc.?
Yes, we definitely have. So the lick wheel is a technology that, of course, being in Florida, you have to be familiar with. We use it quite a bit. The industry uses, I should say. We don't as a research station, but I work hand in hand with the liquid feed industry, and they rely heavily on the use of this liquid feeds. So we've been using that for a long time here in Florida, with the addition of some sort of intake limiter. One thing that I've heard from my peers in the liquid industries, you really need to have some sort of intake limiter. The lick wheel at all or by itself would not limit enough the intake. You still have cattle that may be just sitting by the lake well and just consuming more. So it's a great way to do it. With nitrate, you have to be very careful because the adaptation has to be in a way that they don't overconsume nitrates. So the addition of nitrate through the lake well, at this point, it'll make me a little nervous, but I think it can be done. We really we're a lot more worried about the adaptation than we maybe should have been. Molasses, it's already added through the lake wheel here in Florida very consistently. So I think it's one of the best technologies that we have for convenience delivery of liquids in not only in Florida, but in the Southeast in general.
Okay. I'm going to check with Paula. She thinks she has no more questions. I don't have any more questions. Yeah. Is there question
I
number
have one
2?
more.
Okay. Paula, did you do question number 2?
No, that's the question.
Okay, very good.
Okay. Nico, what do you think about the use of fibrolytic enzymes and about specific ruminal microorganisms supplementation?
That is a good question. So what I think maybe it's exactly what I was just saying with my last slides. I think in the system that I'm working more now, I think in dairy and in feedlot situation where you are delivering the feed every day, it's a little easier, the delivery of those. First, I'll start with the delivery, and then I'll answer what I think about. I mean, it's a very generic question, so there's many different. So, but I'll try to answer as specifically as possible. So, as far as beef systems in grazing conditions or during winter supplementation, the delivery would be the key. And really, that's what I'm after with the enzyme. When I put that slide at the end, I think it will be a great way to start testing direct fed microbials, enzymes, etc. if we figure out a way to treat hay either before baling or before feeding the animal. So what we discussed earlier about adapting the cutter or a hay cutter so that it can sprinkle some type of liquid on top, I think it would be a great thing for the use of those technologies that rely on daily delivery. As far as itself, the use of that technology, I haven't changed a lot. I used to be very reluctant, especially about yeast as a direct fed microbial or other type of direct fed microbials and enzyme. I've seen some really phenomenal advances in that, and I really been amazed by some of the results that I've seen. I do recognize that it is a wide array of different types. Just talking about yeast only, and the people that are in this field can attest to this. There's just so many different types of yeast, whether it's just light yeast, yeast plus the fermentation substrate. There are just so many different types that we have to be very, very careful about generalizing and talking about enzymes in general or yeast in general. And again, the delivery will make a big difference. So if we figure out a way to include that in lake wheels, for example, I think it would be a great way to solve this issue of delivery to extensive systems or grazing systems where we want to maybe use that. It's a huge opportunity, especially on the fibrolytic enzymes field. I see a huge opportunity for that, but we always struggle with the delivery. How do we daily dose an enzyme to cattle that are eating grass or hay? So I think that's a challenge for the future.
Okay. Thank you, Nicholas. This has been wonderful. And thanks for everything that you've done in order to make it so that this could happen. I think that we are out of questions. I have some thank yous from everybody that attended. Felt that it was a good conversation. I'm sure that we will get a lot more attendees listening as a recording. Paula, thank you for joining us. Anyone who listens and wants to know more, Nicholas will be joining us.
Sorry.
Go ahead.
I have just read one question.
Oh.
Sorry. do you think calcium oxide treatments can be made in feedlots at the field scale? And if you have any experience making something like this with rastrojo de maíz, Nico?
Mm-hmm. Okay. Corn stalks or
To
corn residue.
improve digestibility.
Yes. So the question is if it has been done at the feedlot level and with corn stalks or corn residue. It has been done, and actually I have to say the original work with calcium oxide was done with corn stalks or corn residue or corn stover, as maybe the more typical term for what you just say, rastrojo de maíz. So I think that's a challenging fiber type, and because it worked there, it really got a lot of us excited about the possibility of working with other types of fiber or forages. There's some work in Indiana and some work done in Illinois that with calcium oxide added directly to the TMR, and in which corn stalks are replaced part of the corn. Corn stalks treated or not with calcium oxide replace part of the corn. And those studies have been really good. Terra Felix did some of that. John Scootmaker in Indiana did also part of that work, and it definitely does seem to work. I have to say, Paula, what I think it's really happening there, and that's an added benefit when you talk about feedlot. We cannot overlook the buffering effect that this calcium oxide has. So I think more than the effect itself on fiber digestion, we see a bigger impact of the buffering capacity of the calcium oxide in the rumen and improving fermentation or even preventing metabolic disorders such as acidosis, etc. So it has been done. I think it works well. The problem is the logistics on that. On a feedlot where things are a lot more complicated to grind, they already have to grind the stalks typically to add it into the diet. So to add a step to that, which is maybe adding the calcium oxide and then mixing it, anything that creates more complication from a logistics standpoint, particularly on a feedlot, are going to be challenging. So to summarize your question, I think it can be done, has been done, and it works, particularly with corn stalks or corn stover. But it's a bit of a logistic challenge.
Okay, thank you. Nicholas, when you get a chance, if you would send me the links to some of those papers that you referred to, I can share them when I send out all of the recording information.
Yes, that would be a problem.
All right, terrific. I think that we have come to the end of our questions. Again, thank you so much. I look forward to meeting you in person when you'll be speaking at our users meeting at the end of January. So if anybody is interested, it's in Savannah, Georgia, and we can't promise perfect weather, but it'll quite likely be better than wherever you're coming from.
Yes. No, I know it has to be better. So I appreciate.
Yes. So let us know. Just email me directly if you're interested in knowing more about the users meeting at the end of January. And I look forward to meeting you there. Thank you so much, everybody, for joining us. Paula, thank you. And I'll talk to you tonight at 5 o'clock when we have our other webinar.
Yes.
Okay. Thank you, everybody. I'm going to close out the webinar, I think. All right. Thanks. Bye.
Thanks a lot. It's been a pleasure.
Thank you. Have a safe trip home.
Thanks.
Yeah, bye.
Gracias, Nico.
De nada. Adiós.